time queries. Actually, we use the time or we use the queries to verify the times. So here, if we go to the simulator and check the times, we will not see much. We will not see the boundaries. We will not see the value of the x or the value of the time. So we should write some queries. So before we go to the queries and verify the value in these locations, so let's see first how we model the system. Global. So here the system. So here the system. As you see, we have two time meter. This one is, I call it is test, anything, and the second one is the observer. So in the first one, we have the reset and no, and here once this transition, once this edge is taken, that means we send synchronize a message to this second time automator, and something we inform them, okay, this the time is taken. Actually this is should be committed. So if we go to the simulator, yeah, so first once we click OK next, that means we are taking this edge. So once you take this edge, that means you send synchronize to another time automator. So if you see here the time here, the value of x, that is clock, we have only this clock, the value here should be, if you take this edge, you take this transition, the value should be more than or equal to 2. That means the value here starting from 0, but here we start from 2. So go, now we are in the decay, so that means time is more than 2, and then the time should be reset, time will reset, and then go to idle again, and the idle is now start again, that will start, and the time is back again as a condition. I mean here from 0 until 2 take this transition, the time will be more than 2. As we see here, we cannot see much the value of the time, just this condition, okay, x more than 2, so every time x is more than 2. So if you want to see, if you want to ask the value of the time here, when we are taking, for example, the value of is when we are in this state, what the value of x. Also, if we are here the value of x. So just if you want to know that if you want to know that this the value of x in each location or in certain location, you should write queries. You should write queries. So here, for example, if you want to ask about the value in the value of x in the ticket in this location, so we should write queries like this. So what these queries mean? Here we say in all location and all that, all the value or the, if you are in the ticket, then the value will be more than 2. So is it correct or wrong? Is it satisfy or not? Actually here what we have here, x more than 2, more than or more or greater than or equal to 2, right? So once you come here, once you take this transition, that means x should be more than 2. So here we don't have what we can say is the time here is 0. So we don't add any time on these two. So the time here 0. And here we already control the time. We say the time should be more than or equal to. So the time in taken should be more than 2 or not. So let's see. Yes, the time should be here equal more than or equal. So here, okay, this is the graph of that's showing this. We say if the time it will go up. I mean the time starting with 0, but we're starting with 0 in the location nx or in the observable starting. But when we come here, the time should be more than, okay, in the idle, in the loop, the time is 0, for example, and then it should be go up, and then will not take this transition. I will not take this transition until the time is equal to or greater than. So here, this figure is show that. So if we ask about the time in general, the time in all the system. So here we do not specific any location. We just say in all path or in all states, in all path, in all state, in all path, x is greater or equal to. Is it correct or no? So let's see. It's not. Why not? Actually, I already explained why. Actually, when we are in loop or when we are in the idle, the time is starting by 0. But to take this edge, the time should satisfy this guard, and then should go up to 2 or equal to or more than that, or more than 2. So the time is equal to 2 or greater than 2. So this transition will take it. So in the loop, for example, before we go to this transition or this sketch, the time will be 0. And the same thing here in the idle, the time will be 0. So once we get in this transition, the time is greater than, equal or greater than 2. So in the ticking, the time is greater or equal than 2. And then goes to 0 and then back to the idle. So this is if we ask about the time in all system, the time not only greater than 2. The time is greater than 0. It's okay. Greater than 0 is correct. Because the time is starting from 0 and then go up. So if we ask the same question now, the same we say if the time now if we want to ask them about the time here in idle, we say here the time in again it's greater than 0, greater than equal or greater than 2. How about the time in the idle? Actually here, okay, let's see first. Let's see first. The time is not more than 0, not more than 2. Why? The same thing I already mentioned that here we start with 0. So in the loop or in the idle, the time is 0. The time is 0. And then the time it goes up to satisfy this condition. After that, the time, once it satisfies the condition, it will go to decay. So in decay should be greater than or equal to 0, but here it can be 0, here can be 0. So how about the loop? The loop is same. Actually, this location and this location, it's work together in the same. In the beginning, it's the loop, the first time automator, the first location in the time automator will be loop. In the same time, the observer will be also in the idle. So here the time is 0, so we will be 0. So let's now make a small change just to just for more understanding the time. We will make a small change. We will add an invariance, and this invariance in the idle locations. So in the ideal locations, actually we see that in the previous example, we see the time in the curve or the figure, the time it was over than 2 or 3. Sometimes it's 4, yeah, in this figure. We see here the time it goes over than 3. So we can we control the time more than this? We try. So here, this is the small change, just we add invariance in this location. Invariance would mean, so once we add this invariance, that means once x is reached to 3, so it's starting from 0 until here, if x more than 3, it will leave this transition after that. So in the same thing here, we will not leave this one, just we add something here, we add conditions. This condition say you cannot stay if x more than or if x is more than 3. If you see here is this than or equal 3, that's mean if this condition is true, you can stay. So the system will stay in the idle location unless this condition is true. Otherwise, it should leave this condition.
So is there anything will change in the behavior of the system based on this small change? So let's see.
Actually, as we expected, that we are limited the time between 2 and 3. So is this true? So let's see. So how we verify that? We should add invariance similar to the previous invariance. We should add queries similar to our queries and check if the x is only between 2 and 3. So if we write these queries, so here we ask about the time here. Since we are see once it's reset, that means we are taking this location, we are reaching this location. So now in on state, in on back, if we this if we are in the taken location, so we ask x it's always greater than 2 and less than 3. So what do you think the value or the result of this queries? This actually is satisfied because the time here, once you can see, we can see that now the behaviors, it's the time starting with 0, so the 0 it's in loop and so the 0 in idle, 0 0, and then once we when we can leave this, we can leave this one if the time is equal to 2. If equal to 2, so we can leave only if equal to 2 or greater than that. So we can leave. We can leave. Do we have to leave immediately? No, we can stay. We can stay in these locations. We can stay in the idle location or the loop location since it's the same. The machine will start in these two together because both is the initial state. So we are now here in the loop in the idle. So the time is more than 2. So should we leave? Okay, should we leave? We can leave. We can leave, but it's not compulsory. We can stay until the time equal to 3. In the time, if the time equal to 3, we must leave. We must leave. Here we say we can leave because we still there is no another we not violate any condition. So, but here if we stay, that's mean we are broken this rule. So we must leave. So once we leave, so this is will not take time, and the ticking also will not take time. So the time here will be between 2 and 3, because as we said, it is the we cannot stay here more than 0, so the time is between 2 and 3. So and then we reset, and then it's the same cycle is goes again. So here, if we control the time between 2 and 3. So if we just ask about the time is less than 3, so of course it will be the same, because here in idle, if we are in the idle, that means x less than 3, yes, should be satisfied. So here, how it looks like, as we see here, the time starting from 0 go up, but cannot go more than 3, because we are controlling the time here. Actually, this is in the ticking, so the time is controlled. As we can see, the boundary here is 3, so we cannot go over than 3 in this location. In this location, it can go, can start from 0. Here, cannot start from 0.